Hey everyone, welcome to this video. We will talk about reinforcement learning with human feedback, also known as RLHF. So a quick review of what we talked about in the previous video. This diagram is our current understanding of a LLM. So we use large amounts of unlabeled text to pre-train a base model that is really good at next word prediction. This next word prediction will lead to general knowledge, reasoning, and classification in the base model. We can also use few shot prompting on the base model so that it can follow instructions and answer questions better. But it would be nice if we could do this without few shot prompting. So what we will do is give labeling instructions to real human beings to create these conversations between a human and an assistant. And this is data for fine-tuning the base model into an assistant. And after fine-tuning training, we have an assistant model that is much better at following instructions and answering questions compared to the base model. Now, the assistant model training requires human involvement. For creating discussions between a human and an assistant, this data is directly created by humans. People are hired to create the questions and answers for these discussions based on specific labeling instructions. Regardless if the discussions between a human and an assistant are created from scratch or with a large language model's assistance, real human beings will always participate in the discussions being created. This means that creating these discussions between a human and an assistant for training takes a lot of human involvement and time. So, how can we make this a bit more efficient? Well, to start off, LLM next word predictions will use probabilities. While you can make the LLM always pick the next word that has the highest probability, you could instead make the LLM also sometimes pick the next words that have lower probabilities. That was a lot of text. What does that mean? It means that a LLM will have different responses for the same prompt. So if the prompt is, how long does it take for paint to dry? If we have the LLM sometimes pick words with lower probabilities, we can have three different responses. Maybe the first response will say the time it takes for paint to dry. The second response will be the drying time for paint, dot, dot, dot. And the third response will be paint drying time will, dot, dot, dot. And if the model can have multiple responses, we can start having something more efficient. Because ranking responses is faster than creating a response. It is easier and faster for a human to rank several LLM responses from best to worst than it is for a human to create a response from scratch. What's an intuitive way to think about this? For example, it is easier and faster for a human to read and grade 3 essays as either good or bad than for a human to write one essay that is good. For example, if I told you right now, write one essay that is good, that might take you, for example, 3 to 5 hours. You'll have to read a book, maybe, search some articles on the internet, have a good grammar, right? Have good logic, etc. It might even take you, 3 to 5 or maybe 3 to 10 hours to create. But if I just gave you 3 essays and asked you to rank them or say if they're good or bad, that might take you 10 minutes for each essay, maybe 30 minutes for each essay at most. I hope that makes the point really clear. So instead of having real human beings create these essays or these conversations between a human and assistant from scratch, one way we can make things more efficient and speed things up is we pass a prompt to the assistant model, like how long does it take for grass to grow, have the assistant model generate multiple responses, and then have the real human beings, again, instead of creating these responses from scratch, just rank the responses from best to worst. So maybe the best response real human beings will say is this response that says the grow time will vary for different grasses. Maybe the second best response, ranked by human beings, will be something that's more direct and assumes that you are asking about common lawn grass. And then real human beings will say that the worst response is the response where the model gives attitude or is patronizing or condescending back, like look that up for yourself. And so a question that some of you may have right now is, why rank responses? Why have humans rank responses from best to worst? Why not have the humans give the responses a score from 1 to 10 instead? One reason for this is because it is more difficult for humans to agree on a good or bad score. For example, two humans will both agree that a response is good, but one human will give the response a score of 7, and the other human may instead give the response a score of 8.5. Whereas it would be easier to get two humans to agree on which responses to rank from best to worst. However, ranking responses still takes too much human involvement and time. It is easier and faster for a human to rank several LLM responses from best to worst than it is for a human to create a response from scratch. However, having humans rank several LLM responses from best to worst still takes a lot of human involvement and time, even though it is an improvement from having humans create a response from scratch. Having humans rank several LLM responses from best to worst is also work that needs to be paid for. Is there a way to get human judgment, human likes and dislikes, in a much more efficient and affordable way? Let's talk about that in the next slide, where after we have the assisted model generate responses and then have the real human beings rank these responses from best to worst, we'll use these rankings and pass it to a reward model, and this reward model will estimate human preferences and human judgment. Or to put it more simply, if this reward model gets trained well enough and has really good weights, hopefully this reward model will give the same rankings for these responses as real human beings. So just like the assistant model, the reward model can also be a LLM. To train the reward model, see how much its rankings from best to worst match the rankings by an actual human, measure the loss, and then use the loss to update the weights of the reward model. So behind the scenes, the reward model still does all this stuff you see in this diagram that we have gone over multiple times in the course. The model or reward model has weights to give outputs. In this case, the outputs are rankings from best to worst of the assistant model's responses. We use the error/loss to tell the model how correct or incorrect its outputs or rankings are. This error/loss is used to update the weights of the model, so hopefully the model has better weights and gives better outputs, and the process keeps continuing. After training, the reward model should be accurate at estimating human preferences and human judgment. Let's now use the reward model to further train the assistant model. So now instead of having real human beings involved, we just have a reward model. So maybe the prompt is, what is a mammal? And the assistant model generates humans are mammals, which while is technically correct, does not directly answer the prompt or question. So it's not the best response in the world. It's okay or maybe below average. And the reward model, if it is good at estimating human preferences and human judgment, will give a reward model score that reflects that this response could be better, it's kind of mediocre. That reward model score is used to update the weights of the assisted model, and hopefully the assistant model will generate a better response. And the thing I want to emphasize in this diagram again is that no real human beings are involved. So this could be, more efficient, save you time, save you money. And now, what are the benefits of reinforcement learning with human feedback, or RLHF? Let's go over the less obvious benefits first. Number one, it improves the quality of the responses from the assistant model, especially responses that require creativity and may not always have a direct, correct answer. So, what are some creative things that could be helpful? Such as generate a story involving wizards I can tell my kids that teaches that lying is bad, similar to The Boy Who Cried Wolf. Or maybe something else that is creative could be you tell the model, I sell toy cars. Generate a paragraph that advertises that my toy cars are historically accurate and will bring back your childhood memories. What's another benefit? It aligns the assistant model to human preferences and human judgment. What do I mean by human judgment? Well, let's say that we give the assistant model a prompt of how to get promoted at my sales job. And then for whatever crazy reason, this assistant model generates two responses. One response is probably illegal or against the law. Falsely record your sales numbers to be higher than they actually are. Or instead of a response that is possibly illegal, it might give you a response that is just, morally or ethically questionable, like bribe your coworkers for good performance reviews. And we do not want an assisted model to tell you to do something illegal or something that is morally questionable. And if we have a good reward model, it will give bad scores to these two responses, which will be used to update the weights and have the assisted model generate better responses. So yes, that's what I mean by aligns the assistant model to human judgment. We do not want the assistant model to give, responses that are against the law or morally questionable. And of course, the most obvious benefit is that it does everything that was mentioned previously in 1 and 2 in an efficient and affordable way by using a reward model rather than additional real humans. So there's a lot of benefits to RLHF, but what are some things to watch out for? Well, the reward model estimates human feedback. While the reward model is a hopefully accurate estimator of human judgment, it will never be a fully accurate estimator of human judgment because it is not an actual human being. Because a reward model is not an actual human being, it can be affected by reward hacking. So the obvious question is, what is reward hacking? The model could learn responses that get high reward model scores, but are responses that are of low quality and will not be liked by actual human beings. The model could prioritize high reward model scores even if it comes at the cost of quality. That sounds a bit confusing, so let me give you a really obvious example. An obvious example could be a restaurant learns that a famous food critic that really, really likes broccoli will do a surprise review later in the week. So the restaurant wants that good review from the food critic, so the restaurant starts adding too much broccoli to all of its food, leading to less enjoyable meals for other customers. And so maybe in a LLM, when reward hacking happens, the model learns that repeating certain things will get a high reward model score. To get a high reward model score, the model outputs repetitive responses that also make less sense because it will repeat certain things even if it is not relevant. So, RLHF is good in moderation. Why? RLHF will improve a model's response, but if done too much, the quality of the model's responses will get worse because the model will begin reward hacking. So, as the title says, RLHF is good in moderation, but too much is bad for the model. And now, this diagram is our new understanding of what happens in a LLM. We have a base model that, after fine-tuning training, becomes an assistant model, and this assistant model is better at following instructions and answering questions compared to the base model. Then we can have the assistant model generate responses to give to real human beings, and the real human beings will rank these responses to train a reward model that hopefully should be really good at estimating human judgment, human preferences, human likes and dislikes. And after the reward model is used to train in moderation to avoid reward hacking, after it is used to train the assistant model, we should have an assistant model that is better aligned to human preferences. All right, that's it for this video. Thanks for watching.